Lesson 8.5, completing the square. Now let's take a look at a very important part of the process that we're going to learn here in terms of solving any type of trinomial. Okay, now we've been able to factor trinomials in the past, but what we're working towards now is trying to put some pieces together where we have solving square roots like we did in the last couple lessons, and work our factoring into it. Now, in this particular question, we have a trinomial, and what they want us to do is take a look at the two values here, 16 and 64, and see how they're related. Now, if we factored it, the factored expression for this would be x and x. The product of the two factors have to be 64, and they have to add up to 16. When we have gotten quite good at factoring these. Now you notice that the answer, in other words, we have 8 in both places here. How does that relate to the 16 and 64? Well, we notice that 8 is half of 16. Now if you remember this, ax squared plus bx plus c, if we use the terminology in this statement here, we would say that our factor, the 8, is 1/2 of the b term. Okay? So in other words, the 16, so the 8, in the factored form here, 8 is half of 16. Then if you look at the 64, how is 8 related to 64? Well, 8 squared is 64, so 8 squared is 64. So 64 in relation to 16, one would say that, well, if we took 1/2 of b, in this case the 16, and we get 8, so down here it would be 1/2 of 16, and then we squared it, we would get 1/2 16 is 8, and then 64. And there's this relationship here that we want to look at because this is going to pay off for us later. And what we've done here, and the true value of this whole process here, is to show that in this particular trinomial, we ended up having two factors that are exactly the same. So we could write this as x plus 8 quantity squared. And that's important to us, and we'll see why in a moment. Alright, solve each equation by taking the square root of each side. Now, normally we would think, well, let's bring the 36 over, set equal to 0, and so on. But what we're going to do is we're going to make an observation here and say that I think this is factorable as is. So if I factor that, I get x and x, factors of 10 that add up to a negative 20. That would be negative 10 and negative 10. So negative 10 times negative 10 is positive 100, and negative 10 and negative 10 give you negative 20. Now, how does that help us? Well, actually, x minus 10 times x minus 10 can be rewritten as x minus 10 squared equals 36. Now, this looks a lot like the last lesson. But we only could do it because, really, this trinomial happened to factor out appropriately, so that we had the same thing twice, which means we could write it as x minus 10 quantity squared. So it's kind of interesting, and we aren't guaranteed that that will happen every time, but we're going to show that we can actually make that happen every time. So if we undo the square by square rooting, we get x minus 10 equals, and as we mentioned before, in this situation we would have to respect plus minus and then root 36 to get 6. We would then add 10 and we would get x equals 10 plus or minus 6, which leads to two situations. One is we would have x equals 10 plus 6, and the other is to say x equals 10 minus 6, which in one case would give us 16, and in the other would give us 4. Alright, now again, this was factorable in such a way that we had the same thing twice. So let's show how we can actually make that happen. Find the value of c that makes each trinomial a perfect square. Then write the trinomial as a perfect square. Well, like we mentioned before, we said that this value c has to be actually a special number for this to be factorable like the other ones were so far. And we made the observation that this number is half of the b value squared. So if I take 24 and I take half of it and then square it, we get 12 squared, which is 144. So I write this as t squared minus 24t plus 144. Now I might be asking, what about the negative? Well, if I took 1/2 of negative 24 and then squared it, well, negative 12 squared is again 144, so it wouldn't matter. Now, this is a trinomial that is considered a perfect square, because if I factor it, factors of 144 that add up to a negative 24, and that's going to be negative 12 and negative 12. So I could write this as t minus 12 quantity squared. Now again, I could go backwards, and if I did, I would end up with t squared minus 24t plus 144. The question in itself really asks us to find out what c is so that we could do this process. And this is how we did it. When we consider this our b. Let's try the next one. 1/2. Okay, now I think there should be an h here. I want to write that in. I think this is a typo. Okay, so 1/2 of 28 squared. So 1/2 of 28 is 14. If we square that, we get 196. So we would write h squared plus 28h plus 196. Factor it, and we get h factors of 196 that add up to 28. Now it's adding up to a positive 28, so we would write plus 14 plus 14, and that can be rewritten as h plus 14 quantity squared. Okay. Now this example here, or this table here, goes through exactly what I just did. Alright, except when we get into an equation, we're going to add up a couple things here, and this is where you have an equation. Alright, now I'm going to do that step in a moment. But this is what we did do. We took half of b, we squared it, then we added that. Now again, when it's an equation, you'll see how that's going to show what it's going to look like in a moment. Then we factor each side, and we get something squared, and then we would solve it. Alright, now one comment here, and that is that we can only do this process if a is equal to 1. Now so far, and in this lesson, most of these will be 1, and we'll talk about what happens when it's not a 1. And again, what a am I talking about? I'm talking about a squared plus a times x squared plus bx plus c. This has to be a 1. in order for us to complete the square. Like in the last examples, that was a 1. If it's not a 1, we have an additional step. So let's take a look at this one. Now it's an equation, so we're going to solve by completing the square. Now if I factor this right now, factors of 24 that give me 14, I don't have any. I have 6 and 4, 8 and 3, nothing works. But I'm going to come up with a number that will work. So I'm going to, and if I follow my steps, I'm going to subtract 24 from both sides, which gives me w squared minus 14w. I'm going to leave some space there, and I'm going to have negative 24 on the other side. Now what number do I want to put there that will allow me to complete the square? Well, just like in our last example, we're going to take half of 14 and square it. So half of 14 is 7. Square it and we get 49. Now it's an equation now, so if I want to add 49 to this side, I have to add 49 to the other side. And that's again a part of the steps there that said add it to both sides of the equation. Now when I add that to both sides, remember I have to have it balanced. That's why you have to do it to both sides. On the left side, I now have a perfect square, so I can, oops, sorry, let me get that out of the way. I now have a perfect square, so I can factor it. Factor of 49 that add up to negative 14, so negative 7 and negative 7. On the right side, we get 49 minus 24, or negative 24 plus 49. We get 25. This left side is a perfect square, which means I can rewrite it like this. And now we can go ahead and solve by square rooting. Now remember, we created this. It wasn't possible to do this one in this manner. So we took the 24, the constant, and took it to the right side, and then we filled in the blank with a number that would work, that did complete the square. But again, it's an equation, so I have to balance both sides by adding the same amount to both sides. Now when I square root both sides, I will get w minus 7 equals a plus minus 5. I have to add 7. So now we get w equals 7 plus or minus 5, which means two things. W equals 7 plus 5 and w equals 7 minus 5, which is 12 or 2. Now we were able to do this because we completed the square, and that's the process that we're working on with each example and getting better at. Now this last one for today, I think that's the last one here. Yep, we'll do this one quickly. I'm going to subtract 50 and we get n squared plus 18n. I want to add a new number. If I take that, I'm going to get 41 negative. I'm going to take 18, I'm going to take half of that, and I'm going to square it. Half of that's 9 squared is 81. So we have 81 added to both sides because we have to have a balanced equation. The left side is factorable, and it's going to give me n. Factors of 81 that add up to 18 are 9. And 81 minus 41 is 40. And we have n plus 9 quantity squared equals 40. We square root both sides, and we get n plus 9 equals a plus minus root 40. Now my next step would be to subtract 9, and we get n equals negative 9 plus or minus square root of 40. Now we cannot actually take the square root of 40 and get a regular number. We're going to get a decimal, and I'm going to go ahead and do that. And it's 6.325. And that's an approximation, but we'll take it right now. Again, that means two things. It means n equals negative 9 plus 6.325, and n equals negative 9 minus 6.325. And if I do that, I get negative 9 plus 6.325, negative 2.675, negative 2.675. And if I take negative 9 minus 6.325, I get negative 15.325. So an approximation in this case, but that is our answer, and we're done by completing the square. And this ends lesson 8.5, part A.